Thank you again for coming. Today we are going to be we're going to be continuing what we've learned about Observable so far. Last time we learned a little bit about the basics of JavaScript, just sort of the syntax and everything, and talking about how JavaScript and Java aren't the same thing, even though they look alike. They work very differently. JavaScript is inside of every single browser that has been published since like 1999 or earlier even. So it's anything that's web-based has to benefits from or uses JavaScript for any kind of interactivity. It was funny in a lecture I was in yesterday, we were learning about Plotly in R, and which is a wrapper for. It uses R to do JavaScript and to make interactive visualizations and stuff that go into like Quarto documents and whatever. Actually, the slides are all made in Quarto and they have interactive, and it's all great. But it's also just kind of funny. But she was very straightforward. She's like, if you don't have time to learn JavaScript, like this is a perfectly fine thing. But on the other hand, I personally like JavaScript. It feels the idioms feel more normal to me. And yeah, so a couple of the things that came up last time, or that didn't come up last time, but I want to talk a little bit about, is that JavaScript is all computer languages, programming languages have a history of some sort, and some of them are more complicated than others. JavaScript was a little bit complicated because Microsoft created their own version of it before it was standardized. So a lot of early JavaScript development and whatever was done in trying to figure out how to get all of the browsers on the same page. And it took ages to get this done. So if you look at the versions of JavaScript, the first official implementation or specification. Sorry, the first specification was in 1997. Then there were a couple of changes made, and then after 1999 they started making version 4, and they gave up on it. And there wasn't a new version for 10 years when version 5 came out, and then so that was ES5 came out in 2009. ES6 came out in 2015. ES6, so this is something I was thinking about because of arrow functions. Arrow functions were introduced in ES6, or ES6/ what's also now called ECMAScript 2015. ECMAScript is like the official name of JavaScript. It's complicated. But we still write code today for development that assumes that browsers don't support arrow functions, meaning that code is still written today assuming browsers that don't have the 2015 version of JavaScript in it. Back in like 2015, 2016, you were writing code that had polyfills and all this sort of stuff so that it would work on versions of Microsoft Internet Explorer back from Windows XP. And that was just because math showed, like surveys showed, that a lot of computers were running extremely ancient browsers. And there's no, to get the new versions of JavaScript, they have to get adopted by browsers, and then people have to install the new browsers. So that takes time. So arrow functions came out in ES6, and basically before the arrow function, functions are written like this. So this is not, I wouldn't teach it this way, but this is basically, okay, this is an example of an anonymous function. So let me actually see if I can be a little funny here. Okay, so if I were to do this, I would write this like this. I would have const hello to have to use the const keyword, which says that it's a constant as opposed to let, which is for a mutable variable. And then I would have the rest of this. This is this is an anonymous function that we are assigning to the variable hello. Last time we saw that you can also use the syntax of function, then some name, parentheses, et cetera, That's like def. It would be like doing a Python function, except instead of the word def, you use the word function, more or less. That names a function. So it's a peculiar distinction that you can have an anonymous function that is assigned to a variable, or a named function that is not assigned to any variable. I don't remember what the distinction is. Anyway, so this is what we were sort of working with last time, and then now we have the arrow functions. So effectively what happens with an arrow function is the word function disappears and is replaced by this arrow, which is why they're called arrow functions. And then if you want a parameter, you just put the parameter inside the parentheses here. We'll see examples of them. So here's a good example. So this is my function equals a comma b arrow a times b, because this is actually even more of a terseness if the function is just one line of code, which is more often than you might think. Then you don't even need the braces or the return statement, or the return keyword. All you do is write, this is understood as the return statement. So this section of code right here, this is function AB, open brace, return A times B, close brace. So yeah, so we'll be seeing these. Hello, come on in. We'll be seeing these arrow functions shortly, and they're very terse, but it's not terribly. At least to me, it starts to make sense quickly. If you've worked with Python, you've worked with Lambda functions. It's very much like Lambda functions. It's generally the same idea, and well, anonymous functions. But this is just a very terse form of an anonymous function that looks more like the Lambda syntax instead of this whole function syntax. I don't know how to do anonymous functions in R. I know it's possible because I saw a slide with it yesterday, but whatever. Okay, so that's arrow functions. Jeremiah, can you take care of the URL for our, thanks. Okay, so now, and what screen are we on the video?
Oh, I haven't touched anything.
So is it still on the title screen?
It is with you, with Data Club in the corner.
Oh, so nothing on the screen?
Oh, yeah, nothing on the screen.
Oh, so all the stuff with the arrow functions and stuff wasn't.
Sorry.
No, that's all right. That's okay. Nothing is perfect here. Now it is. Okay, so for historical purposes, this is what we had here: before arrow and with arrow. Okay. So if we go to this link, this is the Columbia Data Club group page of observable notebooks. As a reminder, observable notebooks are like Jupyter notebooks, except they are for JavaScript. So here's the one we did 2 weeks ago called Day 1 JavaScript. There's me because we filmed everything, and I later then added the YouTube video into the notebook. So now it's recursive because we have the video of the notebook inside the notebook, so you can just keep seeing whatever. Today we'll be working on this one called Day 1 Data in Observable. So if you go to this URL, you see this list of notebooks, and you pick the Day 1 Data in Observable. As you will see, if you scroll down a bunch, there's a bunch of red stuff that's broken. And we will fix that over time. And then as a kind of treat, I have 3 challenges. One is to write a JavaScript implementation of the 5num_r function that gives the 5-number summary of a data distribution. Then we're going to look at New York City taxi data, and we're going to make a little scatter plot that maps the fare with the tip. And then there's a do your own thing challenge where I have ways to get some Parquet data or your own CSV to just sort of play around in this environment with data that may be more meaningful to you than New York City taxi data. But before we get to these sirens, I have to go through this. So there is, Pandas exists for Python, the tidyverse dplyr, which I just learned that's how you say it. I always thought it was DP, you just said dplyr, dplyr. And the tidyverse is what you have in R, and JavaScript doesn't really have a comparable sort of data wrangling library. There is one that appeared recently called Arquero, which is developed by the people at the University of Washington. They have an interactive data lab. And Arquero works a lot like dplyr, and it's based on the same idea of relational algebra. So a sort of set of verbs that let you do predictable modifications to the data set. And the data format that we'll be using is Parquet. Have any of you used Parquet files before? Yes? What can you tell me about Parquet files? Anything?
It's a lifesaver. It's just we have before that we were using a CSV file,
Okay.
and especially with the date in some chart variables, and
Yeah.
we have problems a lot. Now we switch to Parquet, and those problems are not there anymore.
Yeah, there are basic. Yeah, there. So you touched on one of the biggest differences, which is so data tends to move around on the internet in easily serializable formats, which is to say that are text-like formats, and that can be JSON or it can be CSV, which is just comma-separated values where you have like the first row is the header, first column name, comma, second column name, comma, third, and then the first row is the data, et cetera, et cetera. Something that you're all probably very familiar with. The issue with CSV is that it can set up parsing errors, like what you were saying. Also, CSV is completely agnostic about what the data type is for any column. And as a result, you can create columns that have like mixed data types, like in one row it's a number, in another row it's a string, and then in something like Pandas, Pandas will just call all of that objects and just be like, I give up. Every single data type is an object. And for dates and times, like if you have a typed in date of some sort, then it's just like you have to parse it in some way, etc. Parquet is a binary file format as opposed to a text-based file format. And as a result, one of the things it can encode is the data type for every column. Because typically when you're working with this kind of data, you are working under the assumption that all of the values in a certain column will be of a certain type. They will all be numbers, they will all be a string, et cetera, et cetera. Parquet has 2 other huge wins. By being a binary type, a binary file format, it can be compressed. And oh boy, is Parquet compressed. So I was doing some experiments and getting almost 7 times size reduction between a CSV and a Parquet. So in the taxi data, I have it written down here somewhere. The yellow cab data has 3 million rows, and for July 2024, so there were about 3 million yellow cab, just yellow cab, not Uber, not green cab, just yellow cab 3 million rides in July 2024, and that's a 52.3 megabyte Parquet file or a 344 megabyte CSV file. The Uber, Lyft, etc. is 468 megabytes, 19 million rides in July, and as a CSV, that's 3.2 gigabytes. That's a lot of stuff to be moving over the internet. So that's a huge win. And the third win is something that's not going to be particularly pertinent to us here for reasons you'll see in a second. The third win is that the data is saved in the data structure is saved as columns as opposed to as rows. So like the way, like when you read a CSV file in like Python or something, you're doing like with blah, blah, blah as file read lines. So you're going line by line by line by line. It's a binary format, so it doesn't work quite the same way, but the comparative thing would be column by column by column by column in Parquet. Can anyone guess why that's a big benefit?
You often have fewer columns than you do rows.
Right, but why is it a benefit to have all of one column's data read in at the same time as opposed to an entire row read in at the same time? It's a little niche. So when you're logging something, it makes sense to have, you're logging like a visitor to your website. It's a new row, so you log their IP address, you log the date and time, you log what page they came to, where they came from, et cetera, what browser, whatever. So it makes sense to have lines. Once the data set is finished, so it's no longer July 2024, so we can get taxi data from July 2024, it makes sense to change the data structure so that it's columnar, because then it allows for much faster static analysis. Because then when you want to get the average of, say, the average fare amount of a taxi ride, instead of saying, give me all of the rows, give me just the select taxi amount, fare amount from taxi rides average, or whatever it would be in SQL. Instead, you're just like, just give me the whole column at once. And this is possible in Pandas, it's possible in all these kinds of things, but it requires some kind of in-memory shenanigans. So Parquet is the file format that is much smaller than CSV, that encodes data types and is stored as columns. So it gives for faster analysis. In all of these ways, it's a lifesaver. All we're using Parquet for is copying in a file. Because once you copy in the file, you need to read it in some way because you want to read it into memory. And this is a big thing because a Parquet file, because it's compressed, you have to have the whole file or none at all. With a CSV, because you're reading lines, you can read it as a stream where you only read like 10 lines at a time, which is why you can use you can open up a CSV that's like 3 gigabytes large, even though you don't have 3 gigabytes of RAM on the computer, because it's just reading parts of it at a time. Whereas if you're given this huge binary blob, you have to read the whole thing to decompress it. It comes at a price. So then the second step, our Parquet is the file format, but then the framework for the data in memory is called Arrow. Which is why the library is called Arquero, because it's using the Arrow framework as how it manages stuff in data, in memory. And it has the same wins, especially in terms of columnar stuff. So it reads columns all at a time, as opposed to row by row by row. Okay, so the person who created Pandas and Arrow, so if you want to be jealous of someone who graduated from college in 2007, I think, created both Pandas and Arrow, describes the distinction between Parquet and Arrow. but one is the file format that moves across the internet, and the other one is what gets read into memory. Okay, so our data for today is going to be the classic NYC taxi data. The New York City Taxi and Limousine Commission puts all their data since 2009 up and available. And if you look at 2024, you'll see that they are all in Parquet file format. They used to be in CSV, but they moved to, I'm pretty sure they used to be in CSV. I can't remember off the top of my head. But now they're all in Parquet format, so they're much smaller, which is nice for Jupyter notebooks, but it's still not great for Observable because Observable does have a 50 megabyte cap. I don't know how to get around it. I didn't have time to figure that out. So as a result, we can't even use all of July. I had to make a separate data set of just the first 2 million trips, because that ended up being 40 megabytes or so. So you can see they make 4 different kinds of file formats available. Yellow taxis, do any of you know the distinctions between these 4 different kinds of taxis? It's perfectly fine if you don't. I didn't until recently. Yellow taxis can go anywhere in New York City. Or let me rephrase that. All taxis can go anywhere. Yellow taxis can be hailed, so they can pick up a customer or a fare anywhere in New York City. Green taxis can do the same, but basically everything south of Harlem, more or less, in Manhattan is off limits. So if you stick out your hand for a cab by Central Park, you will, down south, you will always get a yellow cab. If you are in Harlem and you flag a cab, you can get a yellow cab or a green cab. The 4 hire vehicle trip records are the black cars and limos and stuff. And then the high volume for hire vehicle trip records are Uber, Lyft, etc. So these are all huge data files. Sadly, we can't really work with them because of the 50 megabyte cap. But I made a smaller version, like I said. Okay, so very quickly, getting data into Observable. You can do things with using like the fetch API, which is you call up a server and you download the data. This is normally what happens with things like CSVs and JSON. And D3, which is a visualization, etc. library that we'll be working with at the end of the semester, was written by the same person that created Observable notebooks. So D3 is built into Observable now. So you can just do something like this. So taxi zones is one of the files that I have in our Data Club GitHub. Here's where the link is, where I say right above getting data into Observable, there's this link to the Data Club Data GitHub repository. And actually, please do click on that because that's where we're going to be getting the data. So this link here, open it in a new tab, because you will all have to be copying the data in yourselves. So I accidentally made the link straight to here, but that's fine. So this is the file you want to download, is the yellow trip data first 2M Parquet, the biggest one here. And so you just click on that and then do download raw file. And it will ask you where you want to save it. Doesn't matter. Desktop is fine. Well, for me, you have your own systems. And for some reason, it's done already. That was way faster than I thought it would be.
It was very quick.
It may be because all of the Parquet files in this repository are on GitHub's LFS system, their large file system. So that may be much faster. I don't know, or because I definitely haven't downloaded it to this computer before. Awesome. Anyway, if you look here and you go up to NYC taxi data, you see I have a bunch of the metadata, and I describe the metadata here, the different kinds of payment types and rate categories. This is all also in the data dictionary, but I have a couple other little things here too. So for example, there's this taxi zone lookup. one of the things that's tracked in the taxi data is what zone a person was picked up in. And there are something like 250 of them. And they are all around the city. And you can have, so we have this CSV file, taxi zone lookup, and then also a GeoJSON file. I don't know if you have ever used GeoJSON files, but this is a very clever thing that GitHub does. GeoJSON is a way of encoding geospatial data in JSON format. So it's very easy to move around on the internet because it's just one file and it has no projection information or anything. It's just the shapes projected onto the coordinates onto the 1984, the WGS 1984 coordinate system. Or datum and whatever. Jeremiah can correct my terminology. But if you click on it, you see that it shows you what the shape looks like. It's all this purple stuff. We won't be messing with that. We won't have time to get into that today. But in the future, we will. So anyway, so I hope you rather quickly downloaded that data because we'll be using it in a second. Anyway, d3.csv lets you just pass in the way that this function works, d3.csv. You just pass in a URL to a CSV, and then I'll remind you that in Observable, the results appear above. So above it says here, taxi zones is an array that's 265 things tall, and object, 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 object. But if you click on this, you can see, oh, it's just a bunch of objects or dictionaries in Python language that have a location ID, a borough, a zone, etc. And then very conveniently, I don't know if you'll all see this, but there's this little orange pluses and things. And if you click on that, it has some kind of like AI, who knows why it's suggesting this, but it suggests to create a table, and we get this cute little interactive table of the CSV that we brought in. And I think you can maybe like filter based on these things. I haven't played with this, but I just saw that it happens and I was like, oh, this is kind of cute. And yes, so then you can filter here, for example, borough zone versus yellow cab versus, then the last one is like the airports or something. Borough zone is where green cabs can pick up, yellow cabs is yellow only. Okay, so now now things get really interactive because we can't load a Parquet file using the CSV function. Obviously, this is explicitly and exclusively for CSV files. And we can't use the Parquet file to load it with the more generic fetch API. I don't know why. I tried really hard to get it to work, but it wouldn't. It kept saying there was a corrupt footer, which suggests to me that the file was still kind of too big, but I don't know. I'll try with smaller files later. So instead, we have to use a different way that you can get data into these notebooks. So all of this already has been ways of getting data from the internet into notebooks. And there are other ways you can connect your notebook to a database, and you can pass it in like a username and password that's secret, that's hidden from public users of this database and stuff, or of this notebook if you share it. But what we're going to do, and why I asked you to download the file, is we're going to do something like in Jupyter Notebook when you attach a local file to your notebook. So this involves logging into Observable. If you haven't yet, you can just use your GitHub account. So something should show up here in the corner once you're logged in. I don't know that this will work if you don't do this. Then the next step is to fork the notebook. So I will actually do this also. So I will fork it to my own like personal thingy here, the visibility, whatever you want. I will make mine public because I live out in the world. And now I have my own version of this notebook. So you can see it doesn't say Columbia Data Club here anymore, it says my name. So yours should say your name that it probably got from GitHub or whatever. So now when I zoom down here, download the file. Okay, I did that already. Upload the file using the observable paperclip button. Where's the paperclip button? Right here. That looks like a paperclip. So you click on that, and then you click on the plus, and upload the file, and this will actually take, not seconds. Whoa!
It's really fast.
We're on that good internet here.
Oh yes, yeah. Down here is just
Even on Wi-Fi?
they set us up. CRT has set this room up because we do a lot of geospatial stuff down here.
Yeah, but I thought that was just in the walls. Wow. Okay, so hopefully it got, or maybe it's because of all the complaining we were doing about, because we were having so many Wi-Fi problems in this room 2 years ago that were destroying Data Club because they were only hitting Roger, my intern, whose Colab kept crashing. So he would have to restart his kernel and re-download a gigabyte of, anyway. So here we go. So you add the file attachments and it'll have this little thing. And then they very conveniently have this cute little file thingy with the arrow saying, move it from here to here. So you click that, and a little thing shows up here at the bottom called, should show up called something like this, yellow trip data, et cetera, et cetera. And it's using this file attachment module that's built into the into Observable. So this is a sort of funny way of doing something like df equals pandas.readcsv, something like that. But because this is not as simple as CSV, we are actually not yet done. So now I have to zoom all the way up to here. Okay, so you are all probably getting this same error. Okay, delete this little guy. I should have thought about this. So you, so all the way at the bottom, you have this thing. You click on the kebab, and then do delete, and it will say, "Are you sure?" And you do delete. And then you zoom back up here, and it has, so it says first 2M1 here, change that to first 2M, and then it'll say file attachment equals 2M at 1. I think if you just do that, oops. Ta-da! Okay, but now we will have to go and change it everywhere. Okay, that's not a problem. So we have now this variable, yellow trip data, all this sort of stuff put together. We have this variable, and then the next thing down here is this arrow table. And if you open it, you can see what it's doing here. And you will have to change this M1. I'll have to delete it. There we go. And then press play. Oh, sorry, just delete the 1. And then press play. And now what happens here is it's taking the reference to the file and turning it into a buffer. So it's turning the binary data into a stream. And this is stuff that you can just copy paste. You don't have to really think about, but I'll spend 30 seconds describing what's going on here. It turns it into a buffer, and then it turns it into, it like puts it into this array. So it's doing stuff to turn this basically into a stream. And then it reads in the stream into a WASM table. WASM is WebAssembly, which is like the fastest way to do things on the web these days. And then Arrow which I described earlier, creates a table from this WASM table into a stream. So it's all this sort of stuff. This is what's going and turning the Parquet file into an arrow file. And then the next step is we have yellow TB equals AQ, that's arquero, from arrow, arrow table. And now we have a table. And it should work for you all. Do you all have, does it look like this or do you have red? It looks like this? No one has red? All good? Excellent. We can see there are 19 columns by 2 million rows. Fantastic. Now, there's this little thing here that's commented out, yellow tb.view. You can delete the comment and press play. And it'll take a second, I guess. There we go. And now it makes this little visualization for free. I mean, this is all stuff that when Observable was doing it was like, wow, but now it's like built into Colab and built into Jupyter Notebooks and stuff and isn't as impressive. But 3 years ago, this was amazing. But you can see we have the 19 different columns and 2 million rows. There is some funniness here. Does anybody recognize what these date and time, what's going on here in the date and time columns? Why they look like this? Nobody knows what these numbers are?
This is one of those funny formats from starting at a certain date.
That's exactly correct. These are milliseconds since the epoch. So is that something you're familiar with? I know you've heard since the epoch time. Yeah. So it's how much time has elapsed since January 1st, 1970. Yeah. So it's just a good way to describe time with an integer as opposed to words or more complicated forms. It's just an integer. What about times before January 1st, 1970, Moisir? Oh, that's what negative numbers are for. So we have to keep getting stronger and stronger computers because these numbers get bigger and bigger and bigger. So that's that. I'm surprised that they show up this way. I would have been expecting them to show up with a kind of locale, but I haven't really looked into that. Anyway, so now let me see how we're doing for time. Okay, so we have our data loaded in and using the from arrow method. So now here we are in Arquero, and we can look at the data dictionary for the yellow cab data. So if you want to follow along, you can click on this link and it'll open up a PDF. I already have it loaded here. So now this is where this gets to be much more interactive for you all because I want to know from you what of these things are something that you might be interested in finding out about with some data wrangling. So we have the vendor ID. I don't know if this is the little box that you turn the volume down on, or I don't know what it is. We have a pickup date time, drop off date time, location IDs that correspond to the zones, passenger count. We have the categorical variable for rate code that's encoded with numbers. Store and forward flag. I'm not really sure what that, and I don't know if you'll get anything interesting out of it. The payment type, let me actually make this bigger. The payment type, there are 6 of them. I would not have been able to come up with 6 payment types. Credit card, cash, no charge, dispute, unknown, and voided trip. Fare, and then the various different prices involved, including how much the fare was, if there's any kind of extra charges, taxes, then the tip amount, tolls, et cetera, et cetera. So you don't have to say, I really want to know about XYZ now, but start thinking about what would be a fun question to ask of this data. Then we can go back to the notebook, and we can see that there are a bunch of methods and verbs, and then operations, which use the OP namespace. So Arquero brings in an AQ namespace for Arquero functions, and there's an OP for operation functions. So we can see that the syntax is pretty straightforward. Yellow underscore TB dot num rows, just, I mean, it's already playing. I didn't have to press play or anything. It auto updates immediately. 2 million rows. Excellent. And then I had down here, if we go through all the, I'm not going to go through all of these. We can talk about them if you want. But I create a tip percentage, which is made by taking the table, yellow underscore TB. Then in lieu of using a pipe operator or the complete confusion of dot notation and function notation in Python, here it's just all dot methods. So yellow TB dot derive, and this is like mutate, derive a new column called tip PCT. And how do you derive that column? We have an arrow function. Does anybody want to tell me what this arrow function does?
So for each element, it divides the column, the amount by the per amount.
Yeah.
Right?
Yeah, but though it's you're right in saying each element, but that the iterative nature is missing from here. It almost sounds, it almost sounds like it's doing like vector math, like it's doing all of it at once, which it maybe is, but the result is like what you said. For every row, get the tip amount column. So D is data, so the whole table. So for every D, every datum, every row, get the tip amount and divide it by the fair amount and return that. And that becomes the tip percent. And so if we do that, we see that we get an array that's 2 million data points long, or 2 million elements long, where the first one is 22.4%, the next one is 0, the next one is 31. And then I hadn't noticed this before, but we have this little, hey, let's give you a tip, orange plus sign. So let's do a chart. Let's see what it gives us for a chart. Oh, this is fancy. So X is whatever. Oh, it won't let us, because it's only the one variable. What's that going to look like? All right, never mind. Is there a way to do a histogram? Bar? Nope. Okay. Alas, just one variable. Visualizations later in the semester. And then average tip, we do yellow TB roll up, which is like summarize or reduce. And we create a column, or kind of a little bit like doing a group by or a pivot table or something. We calculate a new column called mean, and another arrow function, D, take the mean using the op mean of D tip amount, and then get is the Arquero version of like iloc. So get mean, the 0th index of the mean column. So it's the result of this rollup is a 1-by-1 table with just the one mean and the column mean. But by doing this, we actually get a value as opposed to a table with just one cell. Like if you just press play like this, you see you get a table that's 1-by-1. If you add the get mean, it's like, get me that cell out. Pull that cell out of here.
What did you hit? I didn't get the table 1-by-1.
I commented out get.
Oh.
So then you get a table that's 1-by-1. If you put in the get, that means get a unique cell from the table, even though the table only has one cell. So that's why it goes from being average tip is a 1-by-1 table to average tip is an integer. So the average tip is $3.50. Okay. Challenges. How are we doing for time? Oh, I got through all that a little bit more quickly than I expected, but that's fine. Do you want to do the challenge? All right, the first one is the 5-num challenge. And I said, let's do a 7-number summary, adding in mu and sigma. So how do we go about doing this? I started by creating an arrow function. That's part of the answer, is create an arrow function or a function. So I have, as a reminder, in Observable, we don't use constant let at the beginning of these cells because the way that these cells work is you name 5num is effectively the name of this cell, and the return value of whatever is on the other side of the equal sign is what is assigned to 5num. So we can create a function, for example, called 5num, like this. And then in another cell, we can put in 5num and put in a distribution. This will make sense when you see it in action. And I maybe should have tested this. Hello everybody from the future. I am interjecting myself into this Data Club video to sort of correct the record. We went a little bit off the rails in our group meeting because the challenge I assigned was a little bit too taxing on me mentally. And it was especially frustrating because the issues I ran into were issues I'd run into the last time I had taught Arquero, and I was a little bit dissatisfied with the whole result. So I spent some time to go and think through the specific problems and the specific sort of cognitive blocks that I was having regarding solving this problem. And then I wanted to make this video to go through how I figured it out, and hopefully this will be of use to the Arquero video as a whole and maybe even in and of itself. So to remind the viewer or let you know what the situation was, I created this new notebook that will be part of the Data Club notebook setup. And the issue was how to create a function that gives a 5-number summary of a specific but arbitrary column in an Arquero dataset. And the reason this was so tricky is that Arquero does something a little bit unexpected, which is when you get into sort of the method chaining environment, you start building what are called table expressions. And as they write, and I have ignored this in the past, even though they write it very clearly, when you are doing a table expression, JavaScript, a number of JavaScript features are not allowed. Most importantly, closures are not supported, so table expressions cannot access externally defined variables. Moreover, the only function calls allowed are those provided by the op object. The main reason for this is speed, because when you take things out of the Arquero environment and start using basic JavaScript on them, things have to be changed in order so that the basic JavaScript can work on them, which means that you are sacrificing the optimizations that are provided by something like Apache Arrow. Like the JavaScript array object is not optimized for use with a column of arrow data. So it makes sense to want to stay in using these special operations that do manage to leverage that kind of speed. But it creates for a weird sort of user experience. And one way I was thinking about this was like how things work in something like Spark, where you have transformations to your data set and then you have actions. And the transformations are all done lazily. So you can sit there and do any number of transformations you want, but it won't actually do them until you create an action, which sort of, in my head, prints the data. Or in Arquero's terms, it reifies it. So you get a kind of stabilized new version of the data once you're done with all of these transformations that you only enact when you do an action. And given that Arquero is designed to work well with in-memory arrow data, why would you want to print it? Why would you want to assign a different section of the memory, or however you want to think about it, to hold a different version of the data set? And so this may be not completely accurate, but it's how I sort of think about it. And for an example, I created this toy function that gets the mean of a column of data. And it assumes that the column has the format of an array. So it has a column length, and we can use index notation on it, and it returns the mean. And this is all perfectly fine, but what if that column of data had a built-in mean method that was actually written and optimized for that? It's not going to be the case that this mean I write naively is going to be as fast as some kind of method that would have been built in with whatever sort of data wrangling library I'm using. So Arquero wants us to use their tools and not invent our own tools, which makes perfectly sense, especially at scale. So to remind you what the challenge was, it was to create a function taking any parameters we like, but that works on a specific but arbitrary column of data in Arquero, and it returns something with 5 properties: minimum, first quartile, median, third quartile, and maximum. And I didn't end up implementing this part where I split the grades up into who gets an A, who gets a B, who gets a C, and who gets a D, but I can describe the data set, which is 50 named students. There's an all or nothing final. The maximum number of points in the final is 100. Students tend to lose 20 points on average, and the point loss is distributed in a Poisson distribution, so lambda is equal to 20. So I just created a empty 50 member array in D3 and into it, and then I created 2 new arrays using that original array and map, and created 50 fake names, and 50 times I subtracted from 100 a random sample from a Poisson distribution with a lambda of 20. And I return a data frame in Arquero, an Arquero table. And this is what it looks like. And every time you load this, it'll look different because it's all being done randomly, and that's great. And here is how it looks when you look at it on as a data frame, and you can see all these fun names. I always like reading them, and the various grades. So the naive solution, and what I ended up doing in Data Club after being very frustrated, was sort of feeding in the data and the column name, sorting the data by the column name, and then for each index, because I knew that the minimum would be 0, the maximum would be 49, I would get each specific value by its index. And that gives a correctish answer. We'll see it's not completely correct, or it makes a certain assumption about how you break ties, but it works okay. But the issue is that though the column name is arbitrary, the indices aren't. So then I rewrote it where instead I get the last index available, and then I do some math to figure out what the middle index is and what the first quartile and third quartile indices are. And that works fine. It gives the same results as here. But there are problems here, which is namely that I'm sorting the data. And if you've spent any time in an algorithms course, you know that sorting data is very expensive and should be avoided because sorting is at best n log n. But finding a median, if you do median of medians, is your algorithm. And note, I don't actually know how Arquero finds medians, but if you do median of medians, then it's just n. So it's it's asymptotically cheaper, especially as the data gets larger. So the difference between n log n and n when we have a data set of 50 entries is not that big, but when we're dealing with millions of taxi rides, it becomes somewhat different. So the real challenge is to stay in the idiom, in the arquero idiom, which means to use rollup, which is their reduce type method that's like dplyr summarize. And something like this could work. So we feed in the data, we feed in our arbitrary column name, and then we do data.rollup and then create an object with the new columns. So I write here that this works if I comment this out. So let's comment it out. And we get a maximum of 89. That's correct. But the median breaks. And if we look at the median, the error here, we see what it says. Table expressions do not support closures. So what do they mean here? The issue is that in both of these cases, I'm creating this anonymous function with a D parameter that stands in for the data frame. And this anonymous function with a D parameter, to me, is super idiomatic. And you see it all around the Arquero documentation, and you see it especially in D3. D3, this is how you access the bound data in a D3 method. So if you want to style something and you want to style the color based on some property of the data, you do dot color or whatever it is, or dot fill, then parentheses, and then d arrow d dot color or something along those lines. And so to me, it just felt natural to write this in this way. But the issue is that this creates a closure where there is now a new context, a new scope for this function. And under normal circumstances, a function and an anonymous function named like this would have access to its outer scope. So it would have access to the column name. But as they say here, table expressions do not support closures. So it does not have access to the column name here. The reason this works is because it is not accessing anything outside of its local scope. D.grade is the hard-coded method, or property that gets you the grade column. So there are three, I think I have it written here, yes. So there are three different ways, or at least three different ways in Arquero to get the grade. You could do D.grade, D index grade, or D.column and pass grade in as the string. But in these cases where you have the string in the index or the column method, you need to get that string from somewhere. So either I hard code it like I do here, or I pass it in as column name. So this only works because it's being hard coded. We need to figure out a way to get the median with column name as a variable, as opposed to something that's hard coded. And this is what's really funny, is that the solution is actually super clear, but very unexpected for me, which is we just get rid of the anonymous function. And we just do op-min column name, op-max column name, and we use the quantile function, or the op-quantile method for, or quantile function for the column name with, and we pass a probability, that's the probability break between values. And we get an answer that's very similar, but a little bit different, because we can see here that the median method actually has a rule for tie breaking. When you get based on index, you don't actually get a method that happens if you have a tie. So here it splits the median in half, whereas in the index-based version, it just gives me the lower of the two middle values. So it's not as precise, perhaps, but it's different. And the thing is, I probably never would have come up with this on my own if I hadn't spent hours trying to figure it out in this notebook like I did. Because this is weird. I am passing a string to op-min. So where is the data? I'm not referring to the data anywhere in this method. And in fact, all I'm passing to rollup is an object. But there's no reference to the data. There's no D. I have data.rollup. And so this is what was surprising, was that you don't need to access the data directly. That it's implicit in, I don't know exactly how to talk about this precisely, but it's implicit in sort of the scope inside of this method, that the data is sort of there available and you access it indirectly by doing things like passing column names as strings to min. So min gets a string name and it says, oh, this must be a reference to one of the columns in the data that's sort of hanging out as self or something like that. And that just really struck me as surprising because at least with the anonymous functions, it's still the same thing, data.rollup, and this D comes from somewhere, but at least I'm explicitly accessing it and saying explicitly, give me D.grade or D.column grade. Whereas here, it's just ambiguous. And I was getting a little bit stampy about that until I realized that that's sort of that there are JavaScript examples that do that already, even in the regular language. Like map has access to the array itself, but you still see it as I called it D here. You might call it A instead. So it has this sort of floating access to itself available inside the map function. So it's possible to create an array and then have it return 3 copies of itself. So for each iteration, it returns itself again. So this is just an array of this array 3 times. So that's the D option, but the string option is just very peculiar. But then I started thinking about how you would do this in R with dplyr, and it's even weirder, actually. Because in dplyr, you would do data pipe summarize, and then minimum equals min grade, like this. So you're not even passing a string in, because something about piping the data or whatever gets into summarize creates explicitly, but makes implicitly available objects that are named after each column in the data frame. And this is wild to me because it's grade isn't defined anywhere. Nothing resembling like this. What's going on here? It's extremely terse and not what I'm used to. And so in that sense, maybe Arquero is a little bit more like dplyr than it is like D3. But, these things take getting used to. And I look forward to working on this stuff again in the future. So enjoy, and hopefully Arquero will become clearer to us all as we keep working through it at Data Club. See you next time.